Hello and welcome to our video on using two-way tables to compare data. Now you recall from our previous video that the explanatory variable is the one that explains or causes the response variable. Make sure you've got that little diagram organized. Now when we've got two categorical variables, we can use two-way tables to help us find out whether the two variables are related to each other, so if one causes the other one. And we also use the word associated to say, are these two variables associated with each other? So one way to find out if the two variables are associated is to use a two-way table. The two-way table I've got down here shows data collected to research the question, is a person's attitude to gun control, and the attitude is listed as for or against, is it associated with their sex? So I've got the results here in a two-way table. And the first thing we need to look at is which one's the explanatory variable and which one's the response variable. So we've got attitude and sex, male or female. And we can go, does attitude cause you to be male or female? Does your attitude to gun control cause you to be male or female? Doesn't really make sense. Does your sex, male or female, cause your attitude? That's what we're looking to compare. So we need to swap these around. This time I'm just going to change the direction of the arrow, but that means I need to remember to start my explanatory variable where the arrow starts and the response variable where it points to. So I've just flipped the diagram around. Now that we know this, we know that sex is up here, so the explanatory variable is in columns, male and female here. So this is the total number of male people who were interviewed and the total number of female people who were interviewed. And the response variable is in rows. We could total up here to get 32 plus 30 is 62 people in total are for gun control. So that's our response variable. Don't ask me why there's a line through here. It doesn't mean anything. I haven't crossed it out on purpose. It just happens to be there, so try and ignore it for me. Okay, and I've written this nice little reminder for you that the explanatory variable is always shown in columns and the response variable is always shown in rows. That means if you're just given a table, you don't need to work it out using this little diagram. You could just straight away go explanatory variable, sex, response variable, attitude. Done. If you're unsure, you can go back to the diagram and it's easy to just check if you're not confident. Now going back to our original question, is a person's attitude to gun control associated with their sex? So are the two related? We've got 32 males are for and 26 are against. 30 females are for and 12 are against. So it looks like about the same number of males and females are for and against, but different numbers about the same number of males and females are for, different numbers of males and females are against. And when we look at the total, we can really see where the problem is here. Because out of 100 people in total, 58 were male and only 42 were female. So it's hard for us to compare these two numbers because they're not equal amounts. To make this table easier to read, to see if there really is an association, a difference between the two genders, the best thing we need to do is to convert these numbers into percentages. I'm going to show you how to do this data point in green, change it into a percentage. Oops, if I could draw properly. And I'm going to do it over here to show you how to do it. So we take 32 males out of 58 males in total. multiply it by 100 over 1, or just 100. Actually, I'll do it to one decimal place, 55.2%. That would be 3 significant figures and 1 decimal place. You need to now go through and change each of these numbers into a percentage. Make sure when you do the female category, it's 30 out of the total females, which is 42. So you should have 4 percentages in there, and these percentages should add up to 100% as well. Pause the video now and try that for yourself. And here's our completed table. Hopefully you got something looking like this. You'll notice that each one of these is now a percent, and the totals add up to 100, like I said they would. So these two, so you can check if you're in an exam situation, add them together, they should equal 100. Add these two together, they should equal 100. When we've got the percentage one, we're comparing things equally. So if there was no association and gender didn't influence whether people were interested in gun control or not, then we would expect these row values to be fairly similar. So I'd expect the same percentage of males and females to be for gun control and the same to be against gun control. It's important to remember we're looking across the rows for equal numbers. We're not looking to go down for equal numbers, looking across. Because these numbers are significantly different, we can say that there is an association between the two variables. A few words I'd like to point out there. Significant difference. What's a significant difference? People always ask me. So for the purposes of this, a significant difference will be more than 5% difference. If you've got more than 5% difference, then it's significant enough to say there's association. There is an association. If you've only got 1 or 2% difference, then you can assume that there's no association and they're pretty close to even. Definitely has to be values in a row. We talked about that earlier. And we can say there's an association between the two variables when that happens. Now I have put in a row there, and we've got 2 rows in this example. You might have an example with 10 rows. You don't have to find a difference in every row. You only need to find a difference in one row or a significant difference in one row for there to be an association between the two variables. So it's good practice to just check the first one, and if there's no difference there, check the second one and keep going until you find a difference. If you find a difference on the first row, great, you can stop there. The row where you find the difference is the one that you're going to report on. So we're going to report on the top row because that was the first one we found that had a significant difference. And here's the report I've written. Just put a little heading there. Make that red. Okay. The report says the table, meaning this one, the table shows a greater percentage of females, 71.4%, than males, 55.2%, favour gun control because it's 4. It's in the 4 row. The difference in percentage indicates that for this group of people, attitude to gun control is related to sex. Now that second sentence is something worth putting on the end of every report. What you're doing with your report is the first thing you need to do is quote the data that you are talking about that you found is significant, and we put it into a sentence. Greater percentage of females than males favour gun control. The second sentence is the really important sentence because this is the one where you're going to get all your marks, and that is explain what this means. It's one thing to just say this is what the data says, but you need to be able to interpret it and explain exactly what the data means. And it's also important to put in there for this group of people, or for the people who were interviewed, or for the people in this data set, something like that, because we can't assume that this is for every person in the world. Only 100 people were surveyed, and they may have been all gun owners or all not gun owners. We don't have that kind of information. So we say for this group of people, and we explain what it means. Example 2 shows a two-way table of results asking the question, is sex related to people's attitude towards running horse racing on Sundays? This one I've already put into percentages for you, so you don't need to convert it, so we can easily compare the two percentages. Remember, we're looking across rows to see if there's a significant difference. And 54, only 1% difference, and the second row, 44 and 45, only 1% difference as well. Because both differences are less than 5%, we can say there is no, for this group of data, there's no association between the two variables. And you could write your report same as this report. You could quote either row, but your final sentence would say the difference in the similar percentages indicate that for this group of people, attitude to Sunday racing is not related to sex. For our third example, we have a two-way table showing the results from a survey into the smoking status of adults by level of education. This one is one that has more than 2 rows. So luckily, again, you can see it's got percent written there, so we can easily compare these numbers. If it wasn't, we would need to first convert them. Having a look along the top row, we have 33, 31, 26 and 18. So there's a difference from 18 to 33, which is more than 5%. So there is for this group of people, there is a significant difference, and the two variables are associated. You could also show data in a two-way table, or particularly with more than 2 rows, you could show it in a segmented bar chart. So this is an example of this data put into a segmented bar chart. It was already in percentages, so it was easy to just put into this bar chart. If you were looking at no significant difference, you'd be looking for all of the light blue bars to be around the same length, all of the dark blue bars to be around the same length, and all the yellow bars to be around the same length. So it's just like when you're looking across the rows, you look kind of across the rows of the segmented bar chart. We can see that, for example, this yellow bar compared to this yellow bar, there is a significant difference there, and that's more than 5%. So we can say that there's an association between the two variables. I'd like you to pause your video now and have a go at writing a report on this data. You can choose which row you use to report on, and then we'll go through it together. So when you're writing your report, you need to make sure you, first of all, mention whether you're using the two-way table or the segmented bar chart to write your report. Could have used either. I chose the segmented bar chart. And then mention the statistics you're reporting on. So I chose to report on the top row, the bar chart, so the top, the smokers. Sorry, it's not the top, it's the yellow. The smokers along here, the bottom one here. Segmented bar chart shows the percentage of smokers decreases significantly. Now you needed to have that word there, significantly. You can't just say it decreases, because if we go back to this example here, 55.6 goes down to 54, that's a decrease, but it's not a significant decrease because it's not more than 5%. So you need the word significant or significantly in there somewhere. Percentage of smokers decreases significantly with education level from, and this is where I'm putting my statistics, 33.9, and I kind of cheated and had a look at the two-way table, but that's okay. 33.9% for year 9 or below to 18.4% for university level. This indicates, you must have that section as well. This is part 2. What does the data actually tell you about this group of people? This indicates that for this group of people, smoking is associated with level of education.